Action.
I have not taken any notes after that first test, so I'm just going to be
Not been
catching
to
up.
class
Oh,
until in the past couple weeks.
yeah, I've just been doing the working class, and I'm a little bit worried because that first test, it was a lot dependent on what he talked about in class. So I think the key to doing well on the test is going to be studying his lectures, his slides.
Oh, cool. Exercise. It's awesome. Yeah, diving for it. That's pretty cool.
So much fun.
It's always interesting to see what shows up on other people's Facebook. Oh my god. That's not good.
It's a subject.
Oh my god. For parents' permission. That is pretty crazy.
You have to put the work in for it.
Oh boy.
At all. Whenever you told me that food lab was like the worst and awful stuff, so
How's your bent coming in TVP? Oh yeah. You didn't get enough hours in?
I can, but I don't have time to do my what's it called?
Your bent? Dude, it's actually not that bad. So they make like a really big deal out of it, but then they're not gonna like keep you from joining in the end
I'm panicking about
if
that.
your bent doesn't look perfect.
So if I want to do this,
And I'm taking bio.
I need to do social hours. 2 social hours on Wednesday and 3 service hours on Monday morning.
I don't care.
That's exactly what I did. I did both of the early morning ones the week it was due. It was like Tuesday and Thursday from 4 until 6:30. It was so rough.
I'm taking SATA because I heard his previous exams for executive
I've not started.
exam.
It's not a big deal. You should get some sandpaper and stuff.
And I need to retake the Constitution.
I had to do that too.
I'm playing my trip to the world.
I assume so because they let me join. Yeah, I sucked the first time. I went into the test and I like didn't know half of their names and couldn't remember any of the random facts that they had. But luckily the second one is just like the first one, so as long as you know what to study.
I don't remember any.
Oh boy.
I remember none of it.
I'm debating on taking notes or just sitting and paying attention.
Dude, you're so close, it's worth finishing now. Just saying.
No, it's not. Here's why. Like, in addition to all that, I would need to study, and I have a paper due Monday, 2 tests on Tuesday.
Yep.
If they can give me a convincing reason why it's worth the effort, I'll do it. But if not, I'll drop it right now.
I
So the benefit is to have it on your resume, which is that's a legitimate benefit. Right? You don't think so? No.
What statement does it make?
It's not necessarily a statement. It's not even a statement that it makes to people who don't know about it. Because anyone who doesn't knows so really all it does is for like it shows that you're both intelligent and willing to like be socially active. You do have the GPA. So.
And also if you're in the back, please report.
Yeah, it's not going to be.
See, I'm not Dr. Bickle. I'm one of the TAs. I'm Dan. I'll be running a review session today for the exam on Tuesday. Dr. Bickle will be in the meeting. So I'll just cover potential problems with the exam. I sent out that email a few nights ago. Got a few responses, so we'll prioritize those, and then I'll kind of just pick problems that I think are likely on the exam. So the disclaimer: I have not seen the exam. I don't rate the exam. I don't know what's going to be on the exam. I'm just kind of picking the stuff that's one either kind of the most difficulty on in homework, or I got questions on, or I think the most
I'm doing it for that.
so if I don't cover it today, that doesn't mean it's not on the exam. It just means that either you guys seem to know it pretty well, or it's not as, it hasn't been prioritized. So we'll go through my agenda here. So this is just a review from what on Tuesday. Coverage is chapters 4 through 7, so the most recent assignment will not be on it. And then you bring that comfort sheet, standard size, you can write on both sides. Okay, so the agenda, like I said, I'll run through the questions that I got, answer those as best as I can, and then we'll run through problems. Feel free to raise your hand at any time for questions. Okay, so would you mind giving us a better idea of the types? You know, see that? Is that good? Type/format questions will be asked to solve on the test. An example of a problem type/format, regardless of the specific statistical concept tested, would be helpful. So I can try. I've got a few notes on this. So I think if you looked at the last exam, it's going to be similar to that. He drew a lot of the content from the examples that you went through in class. And those examples are all the ones that are listed in the slides. So if you see on the slides, it says example at the top of it, make sure you know that. That's where you drew the questions from the first exam. You'll likely draw those from the second. The first exam questions, a lot of the probability stuff, he kind of pulls on his own. For the statistics, more statistics stuff, he kind of pulled that a lot more from his book. So I would expect exam 2 to be more similar to this book than exam 1 was. Like I said, that's my expectation, but I haven't seen the test. Second thing I'll say, so the more time that he spent in class on the concept, the more likely it is to come up on the exam. That follows. Let's see. Yeah, the problems I've selected today are the ones that I think are potential most likely to be on the exam. That's just that I don't cover it. It's not. And then if you look at the last exam, all of his problems were focused on applying the formulas and concepts you've learned, not on regurgitating formulas in the sheet. So make sure that you don't just know the formulas, but know how to apply them. Because you're not going to get a question like, what is the correlation of X and Y? Most likely. It'll be, use that to do something. And there'll likely be word problems with multiple parts that test the broad range of what we learned. So that's the first question. Second question, we go over the algebra behind the MLE, so maximum likelihood estimator problems. Yeah, we'll hit that first. We go over estimators and their interpretation. What is the significance of efficiency? What does it mean to be better if both have a bias, and what does bias mean? Okay, so we'll do a problem that kind of solidifies this. But the reason we're using estimators is because we have a sample, we don't know what the actual population parameter is. So if we want to estimate the means, the average height of students at University of Texas, we don't know that. We don't have the data, so we would take a sample of that. And from that sample, we would get the sample mean. The sample mean is not the actual population mean because we didn't sample everybody. So that sample mean is our estimator, and that's why we're using estimators. Bias comes into play because if our sample estimators are routinely missing the population parameters, we want to know that, because ideally they will not be biased. So what does it mean to be better if both have bias? So in general, less bias is better. Actually, not in general, always. Less bias is better, and less variance is better. And so if both of them have the same bias, one of them has less variance, then the one with less variance is better. If both of them have the same variance, and one of them has less bias, then the one with less bias is better. Efficiency comes into play because you may have one estimator that has less bias, and the other one has less variance. So how do you kind of correct that? And that's what efficiency does. Efficiency kind of looks at both of those measures, and you can compare them based on that. So we'll go over a problem there to clarify that a bit more. So third one, could you please talk about the Gambler-Druin equations on Thursday today? No, I can't. So those don't be covered on the exam. That's more of a discrete type problem. The exam starts on continuous. So this is actually, it was a pretty thorough problem, so it takes quite a while for me to go through it. So because it's not going to be on the exam, and because it takes a while, I'm just going to discard that. If you are interested, you can come to Office Hours and I can explain it to you. There's also a pretty good paper online. If you want me to shoot you the link, I can do that. It explains it pretty well. Okay. Just wondering if you could review the cholesterol problem from most lecture 11 slideshow. Yeah, we'll do that. So this is one of the examples. So whoever wrote this question saw on the lecture slide it's an example at the top of it. So that's pretty good example. So we'll go over that. So why is 64.5 used instead of 65? So this question had to do with a normal approximation. And so understanding the continuity correction factor, we'll go over this problem and I'll explain it, but continuity correction factor is important when it works with normal approximation. So make sure you understand how to do that. We go over the quartile formulas. Yeah, we'll do that. Okay. And then if we get through all that, I've got some problems prepared as well. Okay. So the first question we had was about maximum likelihood estimators. So we will look at all this from the book 7-47. This is one of the ones that wasn't covered in homework. I'm going to try and do problems from the book that weren't covered in homework. You can do more variety. So we have a standard exponential distribution, and we want the maximum likelihood estimator of lambda and theta based on a random sample of size n. To simplify things, I'm just going to focus on lambda for this example. So we want to find the MLE for lambda. So first step, first thing we want to do with these MLEs is make sure that we understand the distribution that it comes from. So some of the problems I told you came from a binomial or a Poisson or whatever. Here it's actually giving us the distribution, which is nice. So f(x) is telling us we have lambda e raised to lambda x minus theta. Okay. And so we're told that we have a random sample of size n. So what we're going to do for the MLEs is kind of multiply this by every sample we take. So to do that, we use this symbol. So this is the product equivalent of the sigma symbol. So for sigma, we would add everything together. This one, we want to multiply them together. So we'll do that. We want to do that for our distribution. So one thing we need to do, so for each sample, we need to look at what stays the same and what's going to differ. So lambda is going to be a constant. E is obviously just a constant. Lambda is a constant. For each sample, we're going to have a different x. So because of that, we need to subscript this with xi. Because every time we multiply this together, we'll have, so for the first one, we'll have lambda e negative lambda times x1 minus theta. Then we'll multiply that by our second sample, which will be lambda e and we'll keep doing that for as far as n goes. So the only thing that's really changing is the subscript on the x, because that will change with each sample. Okay, so we've got that. Next thing we want to do is carry this product through to simplify things. So carrying the product through, we're multiplying all these together. So we'll basically, if we simplify this a little bit, we would have, just for this, I'm looking at a small case for when x is 2, but for this one will be the general. So for when x equals 2, if we simplify this, we'd have lambda, pull that lambda over. So we have lambda times lambda. For when n is 2, we have 2 lambdas. When n is n, we'll have n lambdas. So if I carry this product through for the lambda, we'll have lambda for the